Okay, so now we want to look at the operators and in a practical application. So the easiest and the ones we'll start with are the arithmetic operators. And so these are simply the plus, minus, times, division, modulus, increment, and decrement. And so we'll make a few like variables, and we'll just do a heap of printing and changing stuff. So int foo, and we'll set this equal to 2, and we'll go bar equals to 4. So now we have two variables, two integers with two different values. And so we have plus. And so we can, for instance, do printf, plus. And now in here, I don't think I really mentioned what this is. This is string comprehension. And whatever arguments I put into here will get replaced in here, this percentage d. And the d means a decimal, like it's just a standard integer value. So it's not actually a decimal with a dot point, it's just an integer, which doesn't make any sense. But so in here we want to print plus, and so we can just go foo plus bar. Simple, right? And so if we run this, 6. Now, the same way when we have all these arithmetic operators, but we can also use the assignment operators to save these, or I mean, you can just save it normally in a result equals foo plus bar, like this, or you could also say result. If you wanted to just add something to one of the variables, you could then go result plus equals 2. And if we then to print f the result, we would see that result is getting stored the value of foo plus bar, and then we're doing like sort of result plus equals 2. And so this is the same as result equals result plus 2, right? And similarly, if we were to make this 1, we could do 1. We could then also use the plus plus, the increment operator, to do result plus plus, right? So these are all the same. And if we make and run this, we'll see that we have 6. So for instance, it's being stored as 6. We're incrementing it to 7, 8, 9. So that's how we get our result being 9. So now we have the relational operators. And so this is the sort of equals to, not equals to, less than, greater than. And so what we can do here is we could do, I want to store, like we'll get int, or for instance, we'll go result equals foo less than bar, right? So if we make this and we run this, we need another printing of result. We can see here that result is now 1. Now, sort of these relational or logical operators in C, true is anything that's non-zero, but when a evaluation or when a relational operation is evaluated and it results in true, it stores it as 1. So some non-zero and it's always 1. So if we were to switch this around and say foo is greater than bar, like is foo greater than bar, which if we look at it, foo is not greater than bar, and we compile and run this, we can see the result is now 0, which makes sense. So if we had, we could also use, for instance, the equals, or for instance, the not equals. So, but these are more so for conditional statements, which we'll get to in a minute. What do we got next? We've got the logical operators. And so this is when we start to get down into, we need to sort of combine these with the conditional operators. So we'll just deal with some if statements here. So we're looking at logical operators, if, like the AND operation. So foo and bar like comparing them and, so are they both true? Are they both non-zero? So if we say if foo and bar, so this is not saying are they both equal to 1. This is sort of the same as saying if we do I can't remember what the De Morgan's theorems of Morgan's law, this is the same as saying I want to make sure that neither of these are zero, are zero. So this is saying foo should be non-zero. I mean, zero, yeah, I can't explain it. Anyway, so if foo and bar, meaning if foo is non-zero and bar is non-zero, print hooray. And we run this, where's my focus? There we go. We'll see hooray is printed because they both have positive values. Now, if I was to then take foo and replace it with, I'll say here, if foo and result, and we'll just take this, I'm going to say hooray for the second time. We're not getting a second hooray because result is 0. But if we want to say or, so logically, or we just need one of them to be non-zero, then we will get a second hooray. Hooray. Right? Okay. So this is the logical operators, but now we'll move down to the bitwise operators. And so what the bitwise operators do is they compare things bitwise and then they save the result somewhere. And so if you're doing the bitwise comparison of two values, then the result, for instance, if you wanted to logically evaluate it, which would mean that the result has to be non-zero, right? So we're always dealing with this true is something non-zero. So let's do some bitwise operations. So we can look, we have foo and bar, and they're 2 and 4. So we know that foo equals 2, which is in binary 0. Let's just say we'll go with, it's just 4 bits. So we'll say this is foo, and bar is simply 4, which is, right? And so we want to then take the bitwise comparison of the two, and we can say, okay, see if we ended them together bitwise, there would be no result. They don't both share common bits, but we can OR them. So we can say result equals foo OR with bar, right? And so very similar to like before where we were doing these relational operators, this will save the result of this in result, but it will do like essentially the bitwise OR of these two numbers. So if we then print result, we'll see the result is 6. And this is because the bitwise OR of these two is just simply, if we actually go, we'll just make it so that I'm in line, ORed equals 0, B, 0, 1, 1, 0. And this is, of course, binary 6. So then we have that's the bitwise. Then we get onto the assignment operators. And the assignment operator is essentially sort of a combination, like this here is the assignment operator, and they're a way of making these sorts of expressions, these sort of arithmetic operations, just quicker. And so I'm going to go back up here and I'll do a couple more examples. So we can say, if we wanted to, for instance, multiply result by 2, meaning double result, we would say, we can, for instance, take a couple more of these guys and we'll put it down the bottom and do a few. So result multiplies equals by 2. So we saw here result is 6. So now this next statement should print 12. And now we want to say, okay, we'll do another one. What can we pick? We have minus equals. So we can say result minus equals foo. So we're going to double to 12 and then we're going to subtract 2, which we can see here. We have our 6, we've doubled it and assigned it, and then we've subtracted foo's value from results, and it just stores it directly in result. It's just a shorthand, quick and easy way of doing it. So we have these miscellaneous ones, which I won't really go into detail because we'll see these later on when we also talk about pointers. But now we can move on to the conditional operators, which I've also already sort of used here. And so the most basic ones are the if, else if, and the if, else loops, right? And so let's take we'll do essentially the implementation of foo and bar, like the foo one from the lecture slides, and say, so we'll have foo is equal to 2, and we want to do some things based on its value. So we say if, or let's make it even more complex. We can say if foo and bar, we'll put this inside of a function so that we can repeatedly call it simply. Compare, and we'll just say it takes nothing, or it takes, and we'll put these guys globally, so we haven't explained functions yet, so we'll keep things simple. And what we're going to do here is we're just going to run through a conditional operator, like an if statement, a nested if statement, to see the values of foo and bar and do something based off of it, right? So what we're going to say is I'm going to do here a basic statement that tells me if both of them are true, meaning non-zero, if one of them is, or if the other one is, right? So it's like if here foo and bar, so this is the statement where both of them are non-zero, printf both non-zero. Else if, so now we want to say if only one of them is, right? So if foo and not bar, meaning bar is 0, then we will print f bar is 0. And finally, we can do an else, because we know that the only other possible action that can be done is that foo is non-zero and bar is, well, I mean, bar could be also non-zero, but we'll just say, okay, these last two possible actions we will combine into an else statement. So say print f foo is non-zero bar maybe. So there we have a basic little function that we can call that will run through this little step of these little conditionals. And so let's run it. So we've got at the beginning now we have foo and bar both equal to 2 and 4. So we're going to run it here, compare, and we will see that this, for instance, should just print out both non-zero. Oops. So 0. Both non-zero. Great, that's what we expected. So if we go down to here and then we put, for instance, bar equal to 0 and run it again, bar is 0. So it's running in the function, it's coming in here, it's comparing if this, no, this is not true. I mean, because here we have bar is equal to 0. It's going to try the next one. It's going to run this line. It's going to say, oh, okay, cool, great. Bar is 0. Run this code. Finally, if we were to set then foo equal to 0 and run it again, we would hit the else statement. So here we've sort of hit the else condition. Now there is the advantage of the nested if statement is that I'm really doing logic operations here that are not always the same. Foo and bar, and this here is foo and not bar, right? But if I was to just sort of have one sort of constant logic expression and I want to evaluate its result, for instance, then I would be better off using a switch statement. So the switch statement says you give one logic expression and you give all the possible results that it could be, and then you run some value, run some action. And so what we can do is we can say we'll do a switch statement here, or even better, I'll do another another little function, and we'll call this decide or something. And so we're going to switch on, I'll just do foo. Sorry, and then we have the cases. And so what I'm going to do is I'm going to switch actually on foo mod 3, meaning I'm going to, what the modulo operator does, for people that don't know, is it takes some value and it essentially subtracts the largest multiple of 3 from it. So if you had 7, you can multiply 3 to get 6, like that's the maximum times you can multiply 6 to still fit within the number. It will subtract the 6 and it will essentially give you the remainder. So if you do the division, so in C when you do slash, it will return you the number of times it fits in, and essentially modulo gives you the remainder. So 7 slash divided by 6 would give you, divided by 3 would give you 2. 7 modulo 3 would give you 1. So it's saying 2 times 3 plus 1 equals 7, right? So that's what the modulo does. So at most, the switch statement is only ever going to give me 3 options. And we'll implement the first and the second option, and then we'll let the default, essentially the else statement, catch the third option. So when we modulo a number with 3, we can either have 0, 1, or 2, right? 0 if it's a clean, like multiple count, multiple number, whatever the word is. 1 or 2, right? So with a case 0, and then here we'll just say print clean or mod was 0, and then we'll break, right? Because we saw before, I explained before that they fall through, and we'll see what happens when we remove a break statement in a minute. So now we have the second one, print f mod was 1, mode was 1, and then we'll print take the default, and so this is the else, and we'll say print f here, we say mod was 2 in default, and we'll break that as well. So now what we can do, if we go back down to here, I think I'll just split this to make it more visible for us. So we can say foo equals to 7, right? And then decide. Now if we run this, we know that 7 mod 3 is 1, so it's going to do this operation, it's going to do this conditional operation, and it's going to say, okay, cool, this result equals to 1, so we'll go down to case 1. And we can see mod was 1, and now I haven't put in a break. And so we've fallen through and also executed the default case. And this is why we have 2 prints. So if I go up to 23 and put in a break here, we then only get a single print statement, right? Similarly, we'll go down again and we'll then just do foo plus plus, and we'll run decide again. And now we've hit the default. We've gone and done the first one, and now we've hit the default. And so this is what the switch statement does. And it's very good for handling, for instance, like if you had some enumerate like data type where you have all the possible like days of the week, and you wanted to do something on a Monday, on a Tuesday, and a Wednesday, you could just say switch day of the week, and because it's an enum value, they all have unique integer values, and then you say case Monday, case Tuesday, case Wednesday. And it's a really easy way of doing a clean decision based off of one conditional operation. Okay, thank you.